Hello everyone, welcome back to Olsen Cafe. Now today in this lesson, we are going to show that the perimeter of this quadrilateral ABDE is equals to this given expression given by P. Now for question like this, this is usually related to our formula. So now before we move on to proof for P, let us understand the diagram. Now, so over here, what we see that there is a semicircle, which is A, B, C. So in this semicircle, there is a property which we know that right angle in the semicircle, I will have this angle at the circumference here, which is angle B, which is equals to 90 degrees. What I also observe, that there is another right angle over here, given in the triangle D, E, and C. So based on this, observation, I will know that if I have right angle triangle, so which means I will know that for right angle triangle, that means, I will be able to apply so. So that is the first observation. Now, the second observation, that I will have here, in order for us to prove for P, and this is important, so what we see here is you notice that the angle, theta is given here, so which means angle BAC is equals to theta. Now, it is important for us to identify another angle that is also equals to theta. This is a very important skill that all of you must have. Now, so let's take a look. So if angle A, it is equals to theta, and if angle B, this is also equals to 90 degrees, then what will I know is that this angle over here, this angle C, this itself, this will be equals to 90 minus theta. Now, if this is 90 minus theta, and angle E is 90, so where do you think, which angle do you think will be equals to theta? So which means I will be able to identify this angle D here, this angle D, this is equals to our theta. Now, so we know that based on the two right angle triangles, I know where are the theta, then we can actually proceed, to prove for the perimeter. Now, so which means, step number 2, that is important for us to know, is that we must be able to identify theta. It is also equals to angle E, D, and C. So this is the important information that we will need to use later on. Now, so let's go back to the question. So over here, if I want to prove for P, which is equals to 9 cosine theta plus 7 sine theta plus C. Now, let's take a look at what is P. So this is a perimeter, So, which means the perimeter, this will give me, the length AB plus BD plus DE and AE. So let me write this down. So to find perimeter P, this will be equals to the length AB plus BD plus DE, and the last one is plus EA. So if I'm able to find the length of all this, I will be able to prove for P. So let's move on and to start solving one at a time. So let us start with AB. Now let's take a look at AB. So if I look at AB, to find the length AB, what I'm going to do is I'm going to look at the big triangle, which is over here. I'm looking at triangle A, B, and C. So let's take a look at this triangle. So I already know, that theta is here, and this is a right angle triangle, so which means obviously we can use Tuakaso, Now let's take a look. I know that OA as the radius is equals to 4. Now, we will be able to know the length of OC, isn't it? So that means OC is also equals to 4. So based on this information, if I'm going to find AB, so which means, to find AB, what I will have here is AB over AC. This will actually equals to cosine theta. So based on this, that means if I'm going to write AB, all right, in terms of cosine theta, and since AC is equals to 8, so that means I know that AB is equals to 8 cosine theta. Yeah, so which means our AB is done. All right, so next I will move on to find BD. Now let's take a look at BD. Now to find BD, what I do notice is that I know that this length DC is equals to 1 cm. So which means before I can find BD, what I will need to find is I need to find the length of BC. So again, I'm looking at the same triangle here. So what I'm going to have is to find BC, I will have BC over AC, and this will give us sine, because BC is the opposite, right, to the angle theta in the big triangle, all right, and AC is the hypotenuse. So which means I know that BC over AC is equals to sine theta. So based on this, I know that my BC is equals to 8 sine theta. Now, I have found what is BC. What do you think is my BD? So since I know that, right, DC is equals to 1 cm, so which means I am able to work out our BD is equals to 8 sine theta minus 1. So with this, I found the length of BD. Yeah. Now, so once this is done, we can move on to work out the length of DE. All right, so now I want to find what is DE. Now, so if you take a look at DE, so DE now, it is actually at the small triangle, the length of the small triangle. So what I'm going to do is, all right, if it's a small triangle, now what I want to do is I want to focus on the small triangle. So that means I'm only going to look at this triangle over here. Yeah, now, so if I look at this triangle, so what do we have? Yeah, so I have a theta, which is angle D is theta. So I know that DC is equals to 1 cm. Yeah, then how about DE? All right, so based on this, what I can do is I'm looking at this small little triangle. So I have DC, which is the hypotenuse side, all right, and DE is the adjacent. So again, what I'm going to do is I will have DE over DC is adjacent over hypotenuse. So this is actually our cosine. So this gives me cosine theta. So which means, and since DC is equals to 1, right? So that means I know that DE is actually equals to 1 times cosine theta. So which is equals to just cosine theta. So again, my DE is done. Yeah, so with this, I can move on to the last length, all right, the last one, which is EA. Now, before I can find EA, so what do you think we need? All right, you can observe, all right, that we actually need to find what is our length, which is EC, isn't it? All right, if I'm able to find EC, I will be able to find EA. So let's proceed to find what is EC. So again, if I look at this length EC, all right, I know that EC is the opposite sides to the angle theta over here, all right, and then I have DC, which is a hypotenuse. So based on this, so what I'm going to have is I will have opposite EC over hypotenuse, which is DC. This itself will give me sine theta. And since DC is equals to 1 cm, so which means I know that EC, this will give me equals to sine theta. So I found EC, and early on, I already know the whole entire length AC is equals to 8 cm. So which means, all right, I will be able to, all right, work out the length EA. So which means EA is actually equals to 8 minus sine theta. Yeah, so I already found what is EA. So what I need to do is I'm just going to put everything together. So which means I already have my AB equals to 8 cosine theta. I have BD equals to 8 sine theta minus 1. And I have DE equals to cosine theta. and I have EA equals to 8 minus sine theta. So putting everything together, so what I'm going to have is to find P, the perimeter. So this will give me 8 cosine theta plus BD, that is 8 sine theta minus 1. And then I will need to add DE. Yeah, so I add DE, which is equals to cosine theta. All right, and the last one, EA, that is, this give me 8 minus sine theta. Now, once I have this, I'm just going to combine them together. So I have cosine theta plus cosine theta. So therefore, this give me 9 cosine theta. Then the next one that I have here, all right, I have 8 sine theta minus of sine theta, which means this will give me plus 7 sine theta. And then the last term that I'm going to have is, I have here the constant, which is 8, and then minus of 1. And what is 8 minus 1? Which is equals to 7. And with this, I have shown, all right, that my parameter P, it is equals to 9 cosine theta plus 7 sine theta plus 7. Yeah, so we are done. So I hope you find this video useful. Do join me for the next video, whereby I am going to solve this question, all right, and apply it to our formula. All right, I will see you in the next video. Bye.